Let's read this question. A clinic took temperature readings of 250 flu patients over a weekend and discovered the temperature distribution to be Gaussian with a mean value of 101.8 degree Fahrenheit and a standard deviation of 0.806 Fahrenheit. Make sure you understand mean value means this is X bar, standard deviation here is S. Okay, we have two questions. A, what is the fraction of patients expected to have a fever greater than 104.06 degree F? Okay, so the measurement value here is actually 104.06. We need to use the key equation we learned in the class. Z can be approximated using the measurement X, which is 104, subtracted by the mean value right here, 101.8, divided by the standard deviation, which is 0.806. And now the Z value is 2.8. So the Z value of 2.8, actually you see, is right here with the Gaussian distribution curve. The x-axis is Z, and Z equals 0 means that position is equivalent to the mean value. The mean value, the temperature, is 101.8 degree Fahrenheit. You see that? Okay. And then this is Z minus 1, Z plus 1, Z minus 2, Z plus 2, Z minus 3, Z plus 3. And for this value, we are going to work on 104.06. 104.06, the temperature-wise is right here, but the Z value, equivalent Z value is 2.8. And now we are going to use 2.8 to find out the area between Z equals 0 here and all the way to 2.8. Basically, is this region, the area of this region. And if you look at your table, that area is 0.495. So, which means this entire area, this part of the area, that's 0.495. And then for the entire half of the Gaussian distribution curve, the area should be 0.5. All right? And now they ask you to find out the patients, the fraction of patients has a fever of 104.06, greater than 104.6, has a fever higher than this value, which means we are talking about this area. How can we find out this area? This is shaded, highlighted with right. We use the value for the half, entire half, 0.5 subtracted by this area until the 2.8 or until 104.06 degrees. You see? So 0.5 subtracted by 0.495. That's where we got it. So therefore, the fraction of patients expected to have a fever greater than 104.06 degree Fahrenheit is 0.003. Is the 0.003. And that is actually 0.3%. Okay, so it got from the subtraction, the difference between the two, 0.003. That's question A. How about question B? what is the fraction of patients expected to have a temperature between these two? Okay, so between these two. This is different than A, the way it's asked. First, we have to find out the z-value of those two temperatures again. So the first one, let's work on the first one. Okay, we use the measurement, 100.99, 100.99, again subtracted by the mean value, 101.8, divided by the standard deviation is negative 1.0. Again, from the table, you find out when z equals negative 1 or positive 1, the area is 0.341. Now we work on the other measurement on the other end. That's 102.3. 102.53. Okay, measurement subtracted by the mean value divided by the standard deviation, mean value, standard deviation, and then you get a z-value of 0.9. Again, from the table, you will find out the corresponding peak area, the corresponding area for z equals 0.9 is 0.316. Okay, now how do you answer this question? At this point, you see, the person who asked this question wants to know the fraction of the patients with temperature higher than 100.99 but lower than 102.53. So 100.99, that's the temperature. And here z-value, the corresponding z-value is negative 1. The temperature is 100.99, is right here. Okay? Higher than that, but lower than 102.53. 102.53 is right here, and the corresponding z-value is 0.9. So now we know the two areas. The area between negative 1 to 0 is 0.341, and the area between 0 to positive 0.9 is 0.316. What is asked is the sum of the two. You see, greater than negative 1, less than 0.9, or the fever is higher than 100.99, but lower than 102.5. So, which means we are talking about this entire area. You see? So this entire area. Right, from here to here to here to here. And on the left-hand side, this part is 0.341. Right-hand side, this part is 0.316. Then what do you do to answer this question? You perform addition. So the fraction of patient expected to have a temperature between 100.99 and 102.53 degree F should be the sum of the two, and that's 0.657. That's fraction. If you convert that to percentage, that's 65.7%. That's how you solve problems like this.